All right, in this video, we are going to be discussing some ideas of data manipulation or number manipulation when we are thinking in terms of math and electronics and things like that. So the first things we're going to go back and look at is some of the conversions that we can do. Now, we've already talked about the conversions between decimal and fractions, and those are going to be very, very common. We're going to be doing those a lot. So that's just going to be kind of a normal common thing that we do. But some of the other conversions that we have that we need to be looking at is some of the common conversions that we can go through. So with that, some of the ideas that we have is we have pounds, and we can go back and forth into ounces. We've got 1 pound is equal to 16 ounces. So no matter where we're at, we can always convert these back and forth. Another common one that we're going to see is feet to meters. Honestly, after being in the electronics program and dealing with 3D printing and things like that, the metric system honestly just makes so much more sense, and it's so much easier to use, especially when you're trying to convert things. It's really easy. You just go up and down by thousands, you move your decimal point, and you're done. You don't have to worry about some of these weird types of conversions and things like that. So like I said, we can go back and forth between feet and meters. We can go in between inches and centimeters, things like that. I know off the top of my head, inches, it's 2.14 inches is equal to 1 centimeter, and I actually have that backwards. This should be, maybe if it'll erase, 2.14 centimeters is 1 inch. Apologize for that. But having these conversions is what's going to allow us to go back and forth. In some of the future videos, we're going to be talking about some of the common conversions that we have, units, prefixes, all that kind of stuff. And so this will make a little bit more sense when we get into that point. So just understanding that we can convert anything into anything as long as we have some sort of a conversion factor. Like I said, 1 pound to 16 ounces, that's our conversion factor, 1 to 16. Inches to centimeter, 2.14 centimeters to 1 inch. As long as we have some sort of a conversion factor, we can jump back and forth. Later on, when we talk about some of the units and things like that, like I said, we'll get into transferring things from kilo ohms into mega ohms. We'll go down into microamps, into amps, and things like that. And that's just all this is. It's just converting one value into another value or another unit, depending on what we're after. And we'll see more about that as we get going on. So really, that's all we're looking at as far as conversions. So we got conversions. All right, after conversions, we're going to talk about rounding. Now, rounding is going to be a very common, very important thing for when we're dealing with electronics. The values we're going to get are not going to be nice and neat and easy. We're going to have random numbers. We're going to put them into a calculator. We're going to get 14 decimals as far as these numbers go. So what rounding is rounding is a way to simplify our values or our data. And it puts it into a format that's quick and easy to read, but it's also accurate to our needs. So accurate to our needs. Now, when we're running through with these things, if we're trying to say get a robot to move, 1 foot is 1 foot. Whether it moves 1.1 foot or whether it moves 0.9 feet may not be a big deal, depending again on our application. However, if we're looking at these decimals like that, 1 foot versus 1.1 foot, that might be the difference between the robot stopping and rolling off the edge of a cliff, or that robot moving forward and nicking something in a surgery setting as far as like millimeters. If we're supposed to move 1 millimeter, per second, and we move 1.1 millimeters, there could be a chance that 0.1 millimeters comes into play and we nick something that we're not supposed to. So again, depending on our needs, that's where this rounding is going to come into place. So what rounding does, again, is it simplifies our data and it gives us an approximation of our numbers. So this creates an approximation. There we go. And so what this does is we have to figure out where is the line and where do I need to keep this data. So the rules that we have for rounding, and these are the ones that we're going to use and that are generally accepted throughout the engineering community, electronics, all that kind of stuff, is we're going to be looking at the rule, what I call the rule of 5. What that basically means, if the number we're going to be rounding to, so our next digit is going to be a 5 plus, we're going to round up. If it is less than 5, we're going to keep our digit. So what we do with that is, depending on how we want to round, first we have to decide where we're going to round. We look at our information, we go 1 point past where we want to round it, and keeping this rule of 5, if it's 5 or greater, we bump up that number. If it's less than 5, we keep it the same. So we look at this, 3.1415. So we're going to look at the first few digits of pi. So on this one, if I want to round to the whole number, I'm going to look. This is my digit I want to keep, so I'm going to look at my very next digit right here, which is a 1. A 1 is less than 5, so we're going to keep this number the same. So when we round to the nearest whole number, pi simply becomes 3. That's our approximation of pi. If I want to take this number and I want to round to my nearest hundredth, then what I'm going to do is I want to keep my tens, my hundredth place, so I want to round to this value, so I'm going to look 1 past. And again, I'm looking at a 1. 1 is less than 5, so I'm going to keep my hundredth place. So pi then is going to round to 3.14 to my nearest hundredth. And the very last one, if I'm going to round to my nearest thousandth, again, I'm going to look 1, 2, 3, there's my thousandth place. And then I'm going to go look at my next number, which is my 5. So that 5 is going to round it up. So when I round to the nearest thousandth, I'm going to get 3.142, because that 5 means we bump up that value we're looking at. And so pi rounded becomes 3.142. Now again, it matters on the scope. What are we looking at? How accurate do we want these numbers to be? What am I after as far as the accuracy or my error that I can be? In this class, generally what we're going to do is we're going to take our numbers and we're going to round our numbers to 3 decimal places. And usually we're going to do that at the very end of our answer. So when we're finally done, we keep all those numbers in, and then we round it off at the very end point, and we're going to be within a tolerance. So the tolerance that we're looking for in our numbers is we want to be plus or minus 5% of the actual number. So the actual numbers, if we don't round anything off, we keep all the decimals, we go 6, 7, 8, 9, 12 decimals out. That's going to be what's our accepted answer, proper answer. We need to be within the 5% of that. And one of the ways we can maintain that is by rounding to 3 decimal places. So we're going to keep 3 digits and we go from there. Now the cool thing about this is, depending on what we're looking at, when we cut this number off, we want to put it at 140. So on this one, so we rounded to the nearest hundredth, 3.140, meaning we kept that last digit, and that's where we rounded it off to. 3.142, we can kind of have the assumption that we didn't round it, or we bumped it up. Sorry, we bumped it up, not that we didn't round it, we bumped it up rounding. So that would be our number. And if we put this 0 on, just letting us and other people know that we bumped that thing down. And we want to keep all the decimals up to our 3 digits. So in this case, where we bumped it there, we rounded it off to the nearest hundredth, but I'm going to describe this number as 3.140, showing that that's where I rounded and I cut it off. That way people who are coming in behind us can see, oh, this was rounded a little bit, and that's where it was rounded. That's kind of the general consensus and general take that what we do. We can also round these, not necessarily to a decimal position, but we can round them up to a different whole number. So depending on our numbers. So in this case, depending on where we wanted to go with our data, if we had the number 1047365.1267, we're going to go through and we're going to round this depending on what we're looking for. We can round this to the nearest thousandth, we can round it to the nearest hundred, we can round it to the nearest million. So if we look at this, if we round this number, so we're going to round to the millions. So we've got 3, 3, so there's our hundreds, thousands, here's our million point. So we're going to round this guy. We look at the very next digit in our sequence, so 1 to 0. 0 is less than 5, so we're going to keep this million to the same. So we round this number down to be 1 million of whatever it is we are. We just rounded this thing off. If we're going to take this number and we're going to round it to the thousands, okay, so when we round it to the thousands, that is going to be this number right there. So we're going to keep everything in front of it up to the thousands point. We're going to look at our next digit. We have a 3, so that means this is going to keep to the same. So when we round it to the thousands, I get 1047 because it's going to stay the same. And then I've rounded off those last bits of my information. And then again, I can go through and round this off 3 decimal points if I wanted to at the very end, if that's where I needed. Most of the time, we're going to convert this out into an engineering or a scientific notation value, which then we round it off again. That's kind of where this is applying to, is when we get into this rounding, we're looking at how far out does it look at, and how far out do I want my information to go. The point that I want to round, this is where I go to my significant figures or my significant digits. So if I'm looking at this number, I can say round to the millions, and I know where that place is. I have to do a little bit of extra work to figure it out. Or I can just say the number of significant digits I want. So in this case, if I wanted 3 significant digits, I'm going to take the first 3 bits of information. Change colors, so we go here. So 3 significant digits of this number. We're going to keep that 104, and then we're going to round using this value right here. So that means this thing gets bumped up to the 5, and then I put in all my extra zeros up to my decimal point. I can leave those trailing zeros off because really, at this point, when we've gotten 3 significant digits on here, we're not keeping that information much more than what we need at that point. Everything else is going away. So then if I wanted to keep this number, and let's say I wanted to go 9 digits, so I'm going to look, and I'm going to change colors again with this guy. So we're going to go 9 digits. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where I'm going to go. And then I'm going to look at this number. That number is a 6, which means this one's going to bump up. So then this becomes 1047365.13. And I can leave it at that, knowing that I rounded up to 13. If I rounded down, I'd put the 0 just to show that I rounded down from that point. And that's really all there is to it for our data manipulation. Depending on where you round, or where you want to round, how many significant digits you want, all that kind of stuff, that's going to determine the output of the information that we give moving forward. Depending on what the application is, or depending on what we're after, we may want more significant digits, may want more different things, more accuracy, stuff like that. And so again, it's kind of at the discretion of what you're trying to do. But in our class, we're going to be looking at specifically keeping 3 decimal places. That's going to be our significant digits, is 3 decimals. And then we keep everything else in front of it. In class, when we go through some of these examples, there will be times where I just kind of round it off and make the numbers easy and simple just to do some mental math. And with that, we can go through and then find different ways to manipulate the data or look at it and put it into common units to make things easier on ourselves.